Today I am going to discuss some important questions which are generally asked in the board exam based on the topic transformer. Look at these questions. What are different types of losses in the transformer? When we discuss working of the transformer, we assume two cases, two assumptions. First, if there is no flux loss. Second, if there is no power loss. Then we discuss the working of transformer for ideal transformer. Practically, which is not possible. So there are some losses in the transformer which are copper loss, iron loss, hysteresis loss, flux loss, and humming loss. So look at some questions, important questions based on this. What is iron loss in the transformer? Iron loss is due to resistance of iron core and eddy current induced in it. When bearing current flows through the primary coil, there is a continuous magnetization and demagnetization of the core, which causes induced current, eddy current, to flow through it. So due to eddy current and resistance of iron, there is a power loss, P equals to I square R, which is called iron loss. How can copper loss be minimized? First of all, you should know what is copper loss. Copper loss is that due to resistance of copper windings in the transformer. There are two coils, primary coil and secondary coil. When bearing current flows through the copper coil, due to its resistance, there is some Joule's loss, P equals to I square R. This Joule's loss in copper windings due to its resistance is called copper loss, which can be minimized by preferring thick copper wire for making coils. As you know that thick wire has more cross-sectional area and resistance R is inversely proportional to A, so resistance decreases and this copper loss is minimized. What is hysteresis loss in the transformer? Hysteresis loss is mainly due to magnetization and demagnetization of the magnetic material. Just now, I have told you that there is a continuous magnetization and demagnetization of the core due to varying current flowing through the coils, which results some energy loss, which is called hysteresis loss. How can hysteresis loss be minimized? This loss can be minimized by using core material whose hysteresis loop area is less. And soft iron has less hysteresis loop area, so this is preferred for making core of the transformer. What is iron loss in the transformer? Iron loss we have already discussed. This is the Joule's loss in the core of the transformer, core which is made up of iron. So to minimize this loss, what will you do? The next question is, how can iron loss be minimized? This loss can be minimized by laminating core. As you know that lamination of the core reduces the resistance by a very large amount, and this loss is minimized in large amount. What is flux loss in the transformer? This loss is due to improper coupling of the windings, that is primary coil and secondary coil. Sometimes due to improper coupling, flux change in the primary coil does not result the same change in the magnetic flux in secondary coil. So there is a leakage in the flux between primary coil and secondary coil, and this is called flux loss. How can flux loss be minimized? This loss can be minimized by using primary coil and secondary coil by setting it coaxially. If the coils are coaxial, then whatever magnetic flux change takes place in primary coil, same change will take place in the secondary coil also. What is magnetostriction? As we know that through the primary coil, varying current flows, and due to changing current flowing through the primary coil, there is a contraction and expansion in the core. And this contraction and expansion in the core due to varying current is called magnetostriction. Can you transform DC using a transformer? Certainly not, as magnitude of DC is constant. If this magnitude is constant, then there will be no change in the magnetic flux in the primary coil and then in the secondary coil. If magnetic flux does not change, there will be no induction, and as we know that transformer is based on mutual induction, which requires varying current for the induction. Thank you.